Greetings and welcome to my math channel. Today I have a wonderful problem for you from number theory. It isn't that difficult, but there is actually one interesting method. So the question is, find all positive integers m such that this number m factorial plus 12 is a square, is a whole square. So actually, in case you don't know what factorial is, so m factorial is this product actually. M times m minus 1 times m minus 2 and so on way up to 1. So in other words, m factorial is the product of first m positive integers, or in other words, yes, that's a nice definition. So let's continue. And let's just assume that maybe there exists n, which is integer, such that m factorial plus 12 is n squared. Alright, and let's look for all pairs mn which satisfy this equation, which might satisfy this equation. What can we do first? Well, actually, now I will tell you about this method I've mentioned before. So if m is bigger or equal to 5, then m factorial is something like 1 times 2 times 3 times 4 times 5, and maybe that's all, but maybe there's something else. I'll call that something else p, yes, where p is some positive integer. It may be 1, oh sorry, only positive. It may be 1, it may be something bigger. And just because we have there 2 and 5, when we multiply them, we get 10. So in this case, we see that m factorial is divisible by 10. So in other words, m factorial is congruent to 0 mod 10, which is the same that 0 is the last digit of m factorial. Not only that, the last digit of 12 is 2. And so the last digit of m factorial plus 12 will be, of course, 0 plus 2, which is actually 2. And as we know, this is actually n squared, so actually n squared is congruent to 2 mod 10, or 2 is the last digit of n squared. And here comes very interesting theorem. Well, I want to say that n squared can never have 2 as its last digit. Actually, it can have 2, 3, 7, or 8. Let's prove this. Alright, so n can have these remainders modulo 10. So this last digit. It can be 0, it can be 1, it can be 2, it can be 3, 4, 5, 6, 7, 8, and of course 9. Yeah, so these are the remainders modulo 10. So then n squared, how do you find now the remainder? Well, we just have to square all these numbers. 0 squared is just 0. 1 squared is just 1. 2 squared is 4, and 3 squared is 9. But 4 squared is 16, and 16 is actually the same as 6 modulo 10. 5 squared is 25, and this is the same as we say it is congruent to 5 mod 10, and we keep going. This is 36, 49, this must be 64 and 81, and actually we get there 6, 9, 4, 1. So as we can see, there are only these numbers: 0, 1, 4, 5, 6, 9. So these can be the last digits of all squares, of every square. And there cannot be 2, 3, 7, or 8, but only this option. Alright, this is very helpful because we clearly see that this gives us pretty much contradiction. Yes, this cannot happen because there are no such digit as 2 in this set. So we just proved that this case actually gives us no solutions at all. Alright, that means that if there are such numbers, m, m, and m, then m must be maybe 1 or 2 or 3 or 4. Well, because m is less than 5 now. And we just have to check now all these possibilities. If m equals 1, then m factorial plus 12 is 1 factorial plus 12. What is 1 factorial? Well, actually, it's 1. And plus 12 is 13, but 13 is not a whole square, so we don't like this option. M equals 2, well, in this case we get that m factorial plus 12 is equal to 2 factorial plus 12, and 2 factorial is also just very simply to count this number. It is just 1 times 2, which is 2, and plus 12, it's 14. 14 is not whole squares, so no. In case m equals 3, what do we have? Then m factorial plus 12 is the same as 3 factorial plus 12. 3 factorial is actually 6, and plus 12, it gives us 18, which is not a whole square. And finally, the last option. What do we get when we have m equals 4? Well, that means that m factorial plus 12 is equal to 4 factorial plus 12, which is 24 plus 12, which is 36. And yes, finally, this is 6 squared. So actually, we can just say that the only pair of m and n, where m and n are positive integers that satisfy this equation, are m equals 4 and n equals 6. This is the only pair. And yes, 4 factorial plus 12 is 6 squared. It is better to check it once more. Maybe we made a mistake, but no, everything is okay. So the answer is m equals 4 and no other solutions. Thank you very much for your attention and have a nice day. Enjoy math.